Okay, in this video we'll be discussing some miscellaneous topics for our first benchmark. This is the test that we will be having on Monday. Monday, 27th of October. The benchmark is a cumulative review, but in terms of the effect on your grade, it's the same as any other test. It is significant, it's 40%, but no more so than any other test that we have. All right, one definition that we need is zero. And in algebra, when we use the term zero, in addition to meaning the number zero, it will refer to the x-intercept. Zero is an x-intercept. As we know, at both of the intercepts, there is a zero involved, but the term zero refers to the x-intercept. Zero means x-intercept. All right, function notation. We have talked about function notation in a couple of contexts. Basically, it's another way to represent our output, the dependent variable, the y. For example, let's say we had the function y equals 3x plus 7. This function can be rewritten using f of x. And this f of x, this choosing of the f here is arbitrary. It could be g of x or h of x. And the variable that's inside here will always be the input variable. If the input variable were n, then it would be f of n. All right. So I can rewrite this as f of x equals 3x plus 7. So we see the only difference between the two notations is here we're using y, here we're using f of x. If you only remember one thing about function notation, know that it's just another way to say the dependent variable. F of x means y. And that's a loose interpretation, but for our purposes, that'll help you remember. Okay, so with this notation, we could fill out a table. We have our x and our y. If we let x be 1, let's do a little mental substitution, substituting 1 in place of x. 3 times 1 is 3, plus 7 is 10. When x equals 1, y equals 10. Substituting 2. 2 times 3 is 6, plus 7 is 13. When x is 2, y is 13. Here you can see the slope. When x increases by 1, y increases by 3. That's because our slope is 3. Likewise, using our function notation, the same relationship exists. The input is x, the output is f of x. When x becomes 1, f of x, that is y, the function value is 10. When x becomes 3, taking 3 and substituting it in, 2 was the number we looked at. Substituting 2, 3 times 2 is 6, plus 7 is 13. We see we have the same pairings. Nothing has changed there. Let's more explicitly show how we did this. Here I'm going to show substituting 1 into my function. We used to have y equals 3x plus 7. Substituting 1 in place of this x. 1 in for x. This becomes y equals 3 stays the same. Instead of x, we're substituting 1. Plus 7. 3 times 1 is 3, plus 7 is 10. Here we see when x became 1, y is equal to 10. we can write it in a table like this, or we can write it as an ordered pair like this. When x is 1, y is 10. Alright, now we will show the same situation with our function notation. Substitute, we rewrite the function. F of x equals 3x plus 7. This time we're going to take this 1 and substitute it in both positions we see the x. 1 will come here, and 1 will come here. Because x is 1, we're simply taking the 1 and putting it in both locations. Alright, so now I say f of, instead of x1, that's what x is becoming. 3, x becomes 1, plus 7. We don't have to do anything to this side. This is simply our way of saying the y value whenever x is 1. So I rewrite f of 1 on the left side. 3 times 1 is 3, plus 7, that's 10. So we have f of 1 is equal to 10. I'm going to rewrite the notation right here. Here we say when x is 1, y is 10. And here we're saying the same thing. X has become 1, so f of x is 10. We said this is the y. When x becomes 1, y is 10. These two notations are analogous to each other. They mean the same thing. Okay. To say that when x is 1, y is 10 is the same as saying f of 1 is equal to 10. 1 pairs with 10, 1 pairs with 10. All right. Right alongside with the concept of slope, which we've looked at substantially in this unit, is functional relationships. Functional relationships. We know in a function that each x value will pair with a unique y. The phrase we remember, no confused x's. In a functional relationship, each x will know where it's going. An x will not have two pairings. A function has no confused x's. We have learned several terms for pairing the input and output, for calling the input and output. Again, we have x and y, and this y can also be called f of x or g of x or any such thing. Okay, this is the input, this is the output. We can call it either one of these. X is the input, y or f of x or g of x in this case, output. We've also used the phrase domain and range. These two terms here we reserve specifically for the values, the numbers. Okay. So domain are the possible input values, the numbers that x can be. Range, the possible output values. Domain and range refer to the numbers that x and y can take on. Lastly, we've said independent and dependent. While these terms can also refer to the numbers, typically these terms are reserved for the quantities. And what I mean by the quantities are the words we're talking about. Does x represent hours and y represent pay? Does x represent our number of absences and y represent our grades? Independent and dependent are typically reserved for the things we're talking about. All right. In preparation for your test, I would review the flipped videos, particularly the last couple we did, but certainly look at the quiz videos, the 2 quiz videos that are directly adjacent to this video in the flipped videos. Refer to the calendar for Friday or Saturday to verify what I'm talking about.